Oh, hello! Now that you know what sum and difference formula is kind of all about, let's try some and let's try to apply the rules, okay? It's a little bit trickier than the other ones. I think the trig identity is a little bit more difficult, but I think you'll see that it's manageable, okay? Now, before we begin, if you haven't already or you weren't here, just make sure that you've established that these are not the same thing. Oh, sorry, not that way, okay? That means these are not the same thing. I hope you've established that, okay? Try it on your calculator separately and you'll notice that they're not the same thing because clearly they're not distributive property. Duh, okay? This is an angle on its own, right? So you have to realize that. And this is an angle on its own here, separately, and you're adding it together, okay? We've already established that in class. And hopefully you saw some common threads in these formulas to remember, okay? Give yourself mnemonics, like how would I remember this, okay? I always remember as a plus, then it's gonna be plus, minus for sine, it's always minus here. And it's always like, you have to give everybody a chance, right? Like everyone gets one. Okay, and then for cosine, it's a little bit unique too, because if it's a plus or a minus, it's the opposite. And then, of course, it goes cosine, cosine, and then sine, sine for both of them. And then for tangent, I always remember too, because if it's plus here. But on the denominator, it would be minus. Same thing here, minus here, but it's opposite on the bottom, right? Yeah, and then the tan U, tan B, I mean, these things all kind of stay the same. All right, whatever method you do, I think more practice makes perfect. So let's try some. All right. Ooh, okay, make sure you have the formula sheet out and you're using your formula sheet. Like, have it out. But after a while, I hope you're like, oh, I don't need this anymore. Okay? All right, now let's do part 1. Using the sum and difference formula, of course, okay? Now, obviously, we know that these are not going to be the same, right? So we're going to calculate both to checky and to verify that, okay? So let's do this. This one means okay, so first, okay, this will be the first, and this will be our second problem, okay? First, cosine of pi over 6 and cosine of pi over 3. You know what that means, right? I mean, if you still are converting, which I don't advise, is 30 degrees and 60 degrees, which is 90 degrees. Or you can conclude that this guy is actually pi over what? It's pi over what? Okay, you can do it that way. Oh, wait, I hear you. It's pi over 2, right? Because if you think about it, isn't this actually... We're going to do this three ways though, okay? This is actually this is 30 degrees, this is 60 degrees, which becomes pi over 2. So actually you say, oh, but cosine of 90 degrees, isn't that just 0? Okay, well, we're going to get that. We're going to get that using the sum and difference formula, okay? So we've already done this one 2 ways. So A way, and we're going to do a B way using the S&D, which is sum and difference, okay? Sum and difference, which formula should you apply? You should apply this one. It's a cosine, so you know it's going to be cosine pi over 6 cosine pi over 3. But wait, it's a plus. So you know for sure it's going to be minus sine pi over 6 sine pi over 3. I remember this because cosine is a little bit strange. If it's a sum, I always subtract and it goes co-sci, right? Okay, so let's do the calculation now. What's a cosine of pi over 6? It's going to be root 3 over 2. What's cosine of pi over 3? It's a half. Now, if you still have to think about that, get out! Just kidding. Okay, it's just going to be a little harder for you. Cosine of pi over 6 is going to be root 3 over 3. Oh, 2. Sine of pi over 3. Oh, sorry. Woo! That was close. Okay, 1 over 2. Eesh. All right, 1 over 2. What's sine of pi over 3? You're like, Miss Chang, I could do it faster than you. That's wonderful, okay? And you know what you get? You get 0. Whoa, it's the same thing. So we just did that in 2 different ways, right? But now we're going to see how problem number 2. So we did this guy A and B technique. We're going to do C. This guy will be the C, okay? Let's see what pi over 6, cosine of pi over 6 plus cosine of pi over 3. Let's see if they're indeed the same or different, okay? What's cosine of pi over 6? Cosine of pi over 6 is, you already know, what? It's root 3 over 2. Plus, what's cosine of pi over 3? It's a half. Well, then you get root 3 plus 1 over 2. Clearly, that is not 0. Therefore, you've proven also, once again, that sum and difference formula is different when it's sum here as opposed to cosine something plus cosine of something. This means cosine of this particular angle. Okay, so we did this 3 different ways. If I ask you to apply the sum and difference formula, you're going to have to do it this technique. Okay, now if you want, no, let's do one more problem and then I'll give you a freedom to try a problem on your own. Okay, let's move on. Example number 4. Now, these are following the same examples from your textbook. That doesn't mean that this is enough for you to learn everything. This means I'm just filling in the gaps for you from the textbook, okay? Find the exact value of 75 degrees of cosine. Wait. What? Cosine is 75, but cosine of 75 degrees isn't even a special right triangle. You know, this guy right here, this is a special right triangle or special angle, right? But 75 degrees isn't, okay? So you're thinking, wait, how would I apply the sum and difference formula? What do? You try to use what you know to apply the sum and difference formula. So think, what 2 angles that you know that are like 30, 60, 45, 90 that you can use for 75 degrees. So I know there's going to be a lot of variations, right? So you're like, wait, cosine of 75 degrees can be a combination of what 2 angles that you know of? Ding, 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 ding. 45 degrees plus 30 degrees. I know your addition's pretty strong. So you know that 45 degrees plus 30 degrees is 75 degrees, right? So you're like, wait, so I don't need to know cosine of 75 degrees. I don't need a calculator. I could use 30 plus 45 and apply the sum and difference formula. And that's what the power of sum and difference formula is. Whoa. Okay, let's now apply the actual formula. You go cosine 45 degrees, cosine of 30 degrees. Oh, that's ugly. Because you know that cosine is special because cos, and then minus, ding, 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 ding. And then sine of 45 degrees and sine of 30 degrees. And now you just have to do your calculations that you know of using your unit circle stuff, right? Cosine of 45 is root 2 over 2. Cosine of 30 is, what is it? Root 3 over 2. Minus sine of 45 is root 2 over 2. Sine of 30 degrees is 1/2. And you just simplify as much as you can. That's going to be root 6 minus 2, over 2. And this is going to be root 2 over, oh, sorry, I meant 4, right? And then 4. So I get a combination of root 6 minus root 2 over 4. And that is great. Did I do this correctly, you guys? Yeah, I did, right? Yeah. This is good. If you want, you can actually take this further and go, okay, well, I could take out a root 3, and this becomes root 2 minus, oh, what? No, I lied. Okay. Yeah, this is good. Okay. Yeah, I think this is good. I think this is a good answer. Yeah, this is fine. Okay. Sometimes your textbook might show it a little bit differently, but more or less, this is good for our AP Calc and also our class. Okay. Let's try another one. Let's try this one. Now, if you want, you can go ahead and try this one on your own and then stop the video and then look to see the grand reveal, to see if you got it right or not, or see if you already got it. Now, this one's a little bit like different because it's a negative pi over 2, and that's why I chose this question. And we're going to be applying something with the sign, okay? All right, let's try this. Sine of negative pi over 2. I wonder how we can get negative pi over 12, right? Using angles that we know. Pi over 12? That's weird. You're right. But you remember, the angles that we know are very limited. Pi over 4, pi over 3, pi over 6, pi over 2. So you're like, wait, this angle, how can I get that, right? So maybe you could write it with special, like, you know, you could write a negative 2 pi over 6 if you like, right? Because that, I meant 12. You could write this as different angles, right? You could write this as pi over, well, write this, my hint to you is write this using, make the angles that you know, like pi over 4, pi over 3, pi over 6, pi over 2, you know? Make these guys all common denominators of 12 if you like. Okay, then you'll realize really quickly that pi over 4 minus pi over 3. Well, let's try this. Let's make it with a 12, right? So it's going to be 3 pi over 12, right? Okay, minus 12 is 4 pi. Doesn't that equal negative pi over 12? So you're going to have to kind of think that way. It's a little bit tricky, but not really, right? All right, now you're going to be applying the sum and difference formula, but this one is a difference formula because it's a subtraction of angles. So what do? Sine of pi over 4, and you got to take the cosine of pi over 3. Now, sine is the way it is, right? So it's going to be minus, right? And then you're going to go sine of pi over 3, and then cosine of pi over 4. Right? You're basically giving the sine and cosine to one of each, right? Okay. Okay, so now you get root 2 over 2, and then you just do your unit circle stuff. Pi over 3 is 1/2 cosine of. Sine of pi over 3 is root 3 over 2. Okay. And then you got root 2 over 2 here. Okay. Check it out. Check it out. Okay. And then you're like, okay, this is going to be root 2 over 4 minus root 6 over 4 again. So again, it's root 2 minus root 6 over 4. Okay? Yeah. Oh, wow. It's a very similar answer to the example number 4, right? Okay. Digest that a little bit, okay, and ask me any questions and see if there's other ways that you can actually achieve negative pi over 12, not using these two angles. And you'll find that there's actually one more. Okay? Maybe you were thinking pi over 6 minus pi over 4. Dun, dun, dun.